Hi everyone, I am Durga Devi, Assistant Professor from SNS College of Pharmacy and Health Sciences. In this lecture, I am going to discuss about chromatography. In that, we will be studying in detail about thin layer chromatography. So first of all, the chromatography was introduced to separate the organic compounds. These two scientists, they have developed a method to separate chlorophyll, xanthophyll and carotenes from plant products by using a suitable stationary phase as well as mobile phase. So based on this principle, many chromatographic techniques were developed, and the chromatographic techniques can be classified into the related techniques are paper chromatography and high performance thin layer chromatography. And the stationary phase we can use for these methods are solid support and liquid coating, and the mobile phase is solvent. We are going to use this can be aqueous solvent or a non-polar solvent, and the equilibration process is achieved with the help of immiscible liquids with the help of principal partition coefficient. The history of TLC involves in 1938 the plant extracts were separated using 2 mm thick alumina layer on a glass plate, and in 1944 they have used filter papers for identifying amino acids, and in 1950 they have identified terpenes on filter paper and glass fiber paper coated with alumina. And then there is some Stahl's contribution in the preparation of TLC techniques. We can also learn about Stahl's triangle. He have introduced a triangle which consists of the sample mixture, the solvent we are going to use, and the stationary phase. So with the help of the triangle we can easily choose the stationary phase and mobile phase we can use to separate our sample. So his method is a key tool for thin layer chromatography. So first of all, TLC means thin layer chromatography. For performing this thin layer chromatography, we need a stationary phase as well as a mobile phase. The stationary phase used here is a thin layer of either glass plate or alumina plate, and the plates are to be coated with adsorbent materials like silica or alumina. So whatever the compounds which are having adsorption capacity have to be coated onto the solid support, and the mobile phase can be any solvent or mixture of solvents. So in this diagram we can clearly see the mobile phase is kept in a chamber, and the stationary phase is dipped into this mobile phase system after application of samples. And as the solvent keep moving against the gravitational force through capillary action, we can see the samples are separated, and they are all developed into a different spots. They have moved into different distances. So which indicates the red spot indicates it has weak affinity towards the stationary phase, because the stationary phase we have used here is an adsorbent. So if our compound is not having any adsorption capacity towards this stationary phase, then it will move faster. But when you see the blue spot, it is having moderate affinity, so which means it is having some affinity towards the stationary phase, so it is not moving like the red spot. Then the principle involved in TLC is adsorption, because the movement is based on the relative affinity of our sample towards stationary phase. So if the compound is moving at a faster rate, which means the sample is having less adsorption capacity towards the stationary phase, but if it is moving at a slower rate, which means it is having strong relative affinity towards the stationary phase. So it is mentioned, the stationary phase is a stable one and the mobile phase is a moving one. The methodology involves the stationary phase preparation. You have to use a suitable adsorbent to choose to prepare a stationary phase, and then you have to prepare the glass plates by using the different techniques available, that is pouring method, dipping method, spreading method, and then with the help of sprayers also you can prepare the TLC plates. And then you have to develop a chamber with the we need a development chamber to develop the TLC plates, and you have to pour a mobile phase inside the development tank or development chamber, and with the help of detection or visualizing agents you can detect where the spots have been developed, and we can quantitatively and qualitatively analyze the presence of compounds. The stationary phase we can use for preparing the thin layer glass plates are listed here. The most widely used ones are silica, and the remaining were also used for developing the stationary plates. The glass plates we can use can be of the dimensions 20 cross 20 centimeter and 20 cross 10 centimeter, 20 cross 5 centimeter, and we can use some slates also. And here the method used for preparing the slurry and the preparation of plates are shown in the pictures. And you have to apply the sample at a very lowest concentration, because the highest concentration will lead to the development of tailing spots. So in the next video we will be seeing about various development techniques and detection techniques.